This video is going to cover section 4.1, scatter diagrams for UMA statistics. We're going to review a little bit of vocab so that we can go back and forth and see, make sure we understand what we're talking about. So when we're talking about experiments and observational studies, we have response variables and explanatory variables. Response is your effect, like what is happening. And then your explanatory is your cause. So what is causing something to happen? The scatter plot shows a relationship visually between those two variables. Relationship. And we need these variables to be quantitative, because otherwise you can't compare them on a coordinate grid. How do you determine X and Y? Well, X is going to be your cause. Y is going to be your effect. So which is being used as the predictor? That's X. So sometimes it's obvious the way it's worded, but if you can't tell, then you have to read into the study and say, hey, which one is predicting the other one? So here we're looking at the relationship between club head speed, so how fast you're swinging the club, and how far the golf ball goes. We want to know, does the speed of the club predict the distance of the golf ball? So we're going to call the speed X, that's our cause, distance Y. If we wanted to make a scatter plot, we're going to put this in our calculator. So X is going to go into L1, Y is going to go into L2. So we hit stat, edit, and then we type our X, 100, 102. And then we put our Y's in here. All right, now to make a scatter plot, we're going to hit the second key, which is that blue button. Then we're going to hit Y equals, which is right above it. And then we're going to hit enter to get to this screen. On this screen, we want to make sure our plot is on. For your type, you want to choose the one that looks like a scatter plot. And then your X list should say L1. Your Y list should say L2. If it doesn't, arrow down and then hit second one to get L1 or second two to get L2. The marking color can be whatever you want. So that has turned on the scatter plot. Now to see it, we're going to hit the zoom button, which is the top middle, and go down to 9. 9 is stat, so that's going to zoom into the data in the stat menu. And you should see your scatter plot. So X list, Y list, plot on, zoom 9. There we go. Now you see the dots, that's our scatter plot. So if we look at this, we can see it goes up as we move to the right. So as our X, as our speed increases, so does our distance. Now we can talk about that relationship in terms of vocab. So a positive linear relationship is when X and Y both increase. So that's what we were seeing here. The dots go up as you move to the right. Negative, X or Y increases. So one of them is going up, but the other is going down. Decreases. So it's going to go down as we move to the right. Non-linear, you're still going to see a pattern. It's just not going to be a line. So maybe the dots go in a U, or maybe they go in an S. Like you can visually see a pattern. It's just not a line. And then no relation has no pattern at all. So the dots are just kind of everywhere. So if we go back to that, it's going up as we move to the right, making it positive. Numerically, the way to determine this is the linear correlation coefficient. This measures the strength of the linear relationship. It's the variable R. It's always going to be between -1 and 1. It can't be any less than -1. It can't be any more than 1. If R is exactly 1, that means you have a perfect positive relationship. Every dot's going to be right in a line. If R equals -1, you have a perfect negative relationship, meaning it all goes in a negative line. The closer to 1, the stronger the relationship. The closer to 0, the weaker the relationship. Or it's not linear. So if you had one that looked like this or this, you might have a really low R. It's just saying there's no linear relationship. And then R is not resistant. So if you have an outlier or a variable that falls away from the data, it's going to affect that R. So how do we find R? Well, our calculator, again, will do that for us. So once we have all that data in there, we can hit Stat, arrow over to the Calc menu, oops, and then we're going to choose number 4, LinReg. This is the linear regression. We'll talk a little bit more about that later, but we're going to choose that. You have L1, L2. We can choose to store this. So if you go for storing, if you go down there, and then you hit the vars button, which is over here under the arrow over to Y vars, choose number 1, functions, and then hit enter, enter, enter. It gives you this. And we'll talk more about the equation in a later one. What we really care about right now is R, that last number on the bottom. If your calculator does not show R squared and R, do the following steps. If it does show R squared and R, ignore me for a minute. So if R is missing, hit second 0. D. So if you hit X to the -1, it'll bring you to D. Scroll down to diagnostic on and hit enter. So you're going to look for the one that says diagnostics on, hit enter, and then when you do this, you'll have your R squared and your R. So R for this equation right here is 0.939. So that's pretty close to 1. So it's a pretty strong positive line. That's what that R means. So now let's look. Testing for a linear relationship. So we can say, hey, that's pretty good. Hey, that's pretty bad. It kind of depends. But there's actually a mathematical way to prove that we have a relationship. So first we find R, which we just did. We said it was 0.939. And then absolute value is making that positive. So we already have that there. Now we're going to use table 2. So if you go into the back of your textbook, or into the little packet that I gave you, you're going to have table 2, looks like this. It says critical values for correlation coefficient. And then it has N, CV, N, CV, N, CV. Okay? N is the number of data values. So if we're talking about this club head speed, 1, 2, 3, 4, 5, 6, 7, 8, our N is going to be 8. So we go down the columns until we find N8, and then we find the critical value that matches it, 0.707. So N equals 8, critical value is 0.707. Then we compare. If R is greater than the critical value, we say, yes, there is a linear relationship. So 0.9 is bigger than 0.7, so yes, it's a linear relationship. So that's what I just did right here. All right, going back to our very beginning with the observational studies and experiments, correlation versus causation. Unless only experiments can talk about causation. Unless you're controlling all the variables, you can't say it's a causation. So experiments, you can say cause and effect. Correlation, like an observational study, you can just say they're related, but we can't say cause. So a lurking variable, that's a variable we didn't consider. It's something that's connected to both x and y. So we can't separate them. So if we don't account for it, then we can only say causation or correlation. Lurking variables affect our cause. So let's look at this. Because colas tend to replace healthier beverages and colas contain caffeine products, blah, 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 blah. Researchers wanted to know if cola consumption is associated with bone mineral density in women. So this table asked 15 women how many cans of cola they drank and took a study. And their bone density, took a test to do their bone density. So we have 3 questions. Can they conclude a relationship between colas consumed and bone density? Can they consume causation and identify some potential lurking variables? So for A here, we want to know if there's a relationship. So we're going to put the number of cola in L1, the bone density in L2, because we're saying does cola cause? So that's our cause. So in L1, I do 0, 0, 1, 1. Oh, there's only 1, 6. All right, 0.893, 0.88, oops. So type these in. Okay, so those are in there. So now to do our relationship, we do stat, go over to calc, choose number 4. R is negative 8.806. So if we take the absolute value of that, we get positive 0.806. Now we're going to use that critical value table. We know we had 15 people, so we're going to look for N15 and find that our critical value is 0.514. So now we compare those. Is 0.806 greater than 0.514? Yes. So we have a linear relationship. So we typed it in, we found our correlation coefficient, we found our critical value, we said yes, there's a linear relationship. Now we look at cause. Well, in that highlighted sentence right there, it was a study, so no cause, only relation. We can say, hey, they're correlated, hey, they're related, but we can't say cause. And then lurking variables. So what are some other things besides soda that may affect your bone density? So your age, the older you get, the smaller your bone density. Calcium, like do you take calcium supplements? Did you when you were younger? What kind of exercise do you do? Nutrition, weight, any kind of health thing could also be affecting your bone density. Maybe you have a kind of cancer that affects it, like lots of things. So that is 4.1. Let me know if you have any questions.